In this video, we're going to start working our way through the derivatives properties, the different ways you take a derivative based on if it's a power rule or the product rule or the quotient rule. There's proofs for each one. I'm going to set the proofs in separate videos because some of them are a little on the long side. So I'm going to do the proofs in a different video. There'll be a link in the description down below this video for the proofs. I'm just going to do them all in one video. And so you might want to look those over. Some of y'all may not be particularly keen on proofs, but I think it's important. It tells you that these rules are not just made up, they didn't come out of thin air. And to be brutal, some teachers do have you give the proofs on homework or on tests. I happen to be one of those. And so you might want to look those proofs over, not just to satisfy your curiosity, but to be better prepared for some sort of an assessment or a test. So the first set of the power rule, they sort of all go together. There is the derivative of a constant, the derivative of just an x, and then the derivative of x's with powers on them besides 1. Like I said, you should look at the video that's linked below on the proofs. So let's start off with just the constant. So if you had something like y is equal to 6, that's a constant, okay? And according to the proof that you're going to go and look at, the derivative of a constant is 0. Now, why would that be? So if you don't want to look at the proof right this second, for right now, I can kind of demonstrate to you why that is. If you have y is equal to 6 or y is equal to any constant, you have a horizontal line. And as you remember from the previous video, the derivative is actually a slope function that tells you what the slope for some other function is that you can compute anywhere along the original function's length. So if you look at this horizontal line and you remember from algebra that the slope of a horizontal line is 0 because it's flat, has 0 slope. So if the derivative is the slope and the slope is 0 throughout this line, then this derivative is 0. And then the proof gives a different slant on it. So the derivative of a constant is 0. So if I said f of x was equal to 16, the derivative is 0. Well, what about y is equal to x? Again, the proof of this derivative will be in a separate video that has the proofs in it. But let's look at this geographically. Graphically. All right. And think of the y is equal to x line, which looks something like this. So for the y is equal to x line, remember you had 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and the slope of this line was 1. Also, you remember how you have y is equal to mx plus b, and m is the slope, and it's the number that multiplies x. So in this case, y is equal to 1x plus 0, right? The slope is 1. So you can kind of get some verification there that the derivative is 1. I'll give you another reason in just a little bit. Now, let's talk about the power rule as you often see it. And if you had something like y is equal to 3x to the 4th, right? So you have a coefficient of 3, a power of 4. There's a very expansive proof for the power rule. So again, check the description. So the rule for this is that let's set this up. The derivative with respect to x of x to the nth power is n x to the n minus 1. So what this says is you're going to bring the power down in front and then take 1 off of this original power and put it right here. So let's practice. So you'd have your 3. You're going to bring the power down in front, leave the x alone, take 1 off of the original power, that would leave you 3. And so y prime would be 12x cubed. Okay? So let's try some more complicated versions to practice. And let's find the derivative of this function. Now, I'm going to take this really slow. You can certainly do some of this in your head or write it out to the side and go a little faster. But I'm assuming if you're looking at this video, you just need a little bit of assistance. So let's go through that. So this is a polynomial. You have 4x cubed. You write the coefficient down. You bring the power down, leave the x alone, take 1 off the power, so that would be squared. Minus 6, bring the power down, leave the x alone, take 1 off the power, this would be 1. Or leave it blank, it's understood 1. Plus 3, and the derivative of x is 1. And the derivative of a constant is 0. Now you don't have to write the 0 down. You don't have to write the 1 down. I'm just showing you all the steps. I want to show you another reason that I think you could come up with this one right here. So let's do the power rule. Okay, you have your 3. You bring the power down. You leave the x alone. You take 1 off the power, so that would leave you 0. Anything to the 0 power, according to algebra, was 1. So literally you have 3 times 1 times 1, which is 3. Or you can look at the proof. Okay. Hate to keep harping on that, but you really need to do that. So you clean this up, and you have 12x squared minus 12x plus 3. Now, you can do more derivatives if you want. So that's the first derivative. You could do a second derivative. A second derivative would be the derivative of the first derivative. Okay, so here's the first derivative. We're going to do the derivative of this. So you would have your 12. You'd bring the 2 down, leave the x alone, take 1 off the power. So this would be an understood 1. Minus 12, the derivative of x is 1, and the derivative of a constant is 0. So you would have 24x minus 12. You could do this for a while. Let's do it again. So the third derivative, which is the derivative of the second derivative, you have your 24. The derivative of x is 1. The derivative of minus 12 is 0. So the third derivative is 24. Now, after they get to this 3 little hash marks for the third derivative, I've seen it to where they either go f and they put a little 4 right here, or they'll put f and put a Roman numeral 4 right there. So this is supposed to be a 1 and a v for that Roman numeral. So the derivative of a constant is 0, and so the derivative of 0 is 0. So all of the rest of these down here are 0. And so sometimes people will put on a test or something if you're given some sort of function, whatever that is, and they'll ask you for the 99th derivative. So unless this is like x to the 102nd or 100th or whatever, then all of these are going to be 0. And it's just sort of a trick question. Right. Now, it doesn't have to be x's. if you have r of t is equal to 8t cubed plus 5t squared minus 2t plus 42, you take the derivative with respect to t. So in the definitions in the proof, they'll talk about derivative with respect to x, but then there'll be x terms in here. You could do the derivative with respect to t for things that have t's in here. All right. Now, so we're going to take the derivative of r of t. We're going to call it r prime. So we have our 8. We bring the 3 down, leave the t alone, take 1 off the power. Plus 5, bring the power down, leave the t alone. There's a reason I keep saying leave it alone. It's for later. Take 1 off the power. Minus 2, the derivative of t is 1, and the derivative of 42 is 0. So r prime of t is 24t squared plus 10t minus 2. There you go. Let's do one that's a little working on your fractions. So y is x to the 3 halves minus 6x to the 2/3 plus 3x to the minus 1/3 plus the square root of 6. So now when you take the derivative of y, don't just put an equals here and start writing and say, okay, I'm going to bring down the power, leave the x alone, take 1 off the power. Don't start writing and assuming that you can just do equals all the way down, because this says y is equal to x to the 3 halves. You can't, if you don't put something right here, you're implying falsely that you're still talking about y, and it's going to look completely different. So you have to tell the reader, which is your teacher, that you're talking about the derivative, not the original function. So you'd bring the 3 halves down, leave the x alone, take 1 away from the power, and 3 halves minus 1 is 3 halves minus 2 halves, so this is 1 half. Okay, minus 6, bring the 2/3 down, leave the x alone, 2/3 minus 1 is minus 3/3, so you would have minus 1/3 plus 3, bring the minus 1/3 down, x minus 1/3 minus 3/3. Okay, is what? Minus 4/3. And the derivative of a constant is 0. I'm not going to write the 0 down. So y prime is 3 halves x to the 1 half. Okay, 3 goes into 6 twice. Minus 4 x to the minus 1/3. Positive times a negative is a negative. 1/3 of 3 is 1. X to the minus 4/3. All right, now, since this original problem had a negative power in it, it's considered good taste or good form that if you have negative powers here in your result, that's okay, that you do not need to go through and fix them. Remember how in algebra you're not allowed to have negative exponents. You're supposed to say, okay, this is 4 over x to the 1/3, and then you would have to clean up that cubed root. So the fact that they started off with a root, right, and the fact that they started off with negative exponents means I can end up with those in my final answer and box it in as that. Because it's like saying, okay, a client or someone who just has a question asked me a question and said, here's your question. I need you to take the derivative for me, and you get this answer down here. And then you go, well, actually, this is wrong. This should be 4 over x to the 1/3, which is 4 over the cubed root of x, and then you need to rationalize the denominator. It's almost like you're telling them they were bad form asking you that question, I guess. I don't know. I like to make up stories so that I'm not angry about what's being asked in math or when the rules change. So I kind of make up stories about people and who's happy and wants to go over here or whatever. So I make up stories like, okay, I don't want to be rude. Okay, I want to change it this way. Your teacher, however, may decide that what they want to do is make you practice the rules that you learned in algebra and have you straighten up, I'll put in quotes, these negative exponents by dropping them into the other side of a fraction bar. You need to follow whatever pattern your teacher is demonstrating for you, or if you're not sure, you need to ask them. Now, let's talk about this next problem. And this is kind of a little different, and I need to talk to you about kind of strategy things. It's supposed to be a 1/2. Looks like a y. 1/2. Sometimes I make my fractions like this, and sometimes it's like that. All right, now, this is sort of an important concept, so I want to talk to you for just a second. In the past, for most of your math career, most likely, the problems that you were given were pretty straightforward. They asked you a problem, it was in the format it should be in, and maybe you needed to factor it to solve it or square root it or something, but the initial shape that it was in, its appearance was satisfactory, I guess, and the procedure adjusted from there. But here, when we're taking the derivatives, if you don't like the shape that the original problem is in, you can change it to something that you prefer to work with. Now, for right now, you don't have anything to change it to because you don't know any of the other rules officially yet. So we're kind of stuck with just this one. But by the time we get through all the rules, if you don't like the way something is set up, you can change the setup to something you prefer. And we'll talk about that more when we get to after the end of the chain rule, which is in a couple of videos. So let's look at this one and go, let's pretend this is on our test. And we look at it and go, well, great. I only know the one rule, really. I only know the power rule, and then constants, that sort of stuff goes with it because in a constant, the power is 0 and the derivative of x is 1 is power of 1. So that's really all I know. And you're looking at this going, I don't know anything that looks like this with a fraction and tops and bottoms and everything. Is there some way that I could make it look like this plus this minus that or whatever? And you go, since this is a monomial in the bottom of the fraction, I can write this as p squared over p to the 1/2 minus 2p to the 3/2 over p to the 1/2. So I can separate it by repeating this denominator, but that only works when you have a monomial. Now this is still s. I have not taken the derivative. So let's see what I can do with this. So p squared over p to the 1/2. You write the p down, start with the top and subtract the bottom, right? Minus 2p, start with the top power, subtract the bottom. So this is p, and 2 minus 1/2 is 3/2 minus 2. P to the 3/2 minus 1/2 is p to the first, right? Now, sometimes I see students work problems like this, and I think they just get distracted or kind of lose track of where they're trying to get. But because they're doing this subtraction thing right here and working with variables, it makes the mind think they've actually taken the derivative because they've been busy changing the format. And you're just not used to this concept of changing the initial problem setup, but you have not taken the derivative yet. So let's keep going. Now I have it in the format that I'm used to for the power rule. So I'd bring the power down, leave the p alone, take 1 off the power. 3 halves minus 1, which is 2 halves, is 1 half. Minus 2, and the derivative of x is 1, so the derivative of p is 1, and this would be your final answer. Okay. Now, let's try another one. Here's f of x equals to 4 cubed root of x squared plus 6 cubed root of x over 12 cubed root of x squared. Now, derivatives don't understand square roots, okay? Derivatives understand powers. So I've got two things going on here. I don't know how to do a fraction derivative yet. You'll know after the quotient rule. But I know the power rule, and I have a monomial down here in the bottom. It's one term, so I can split it up. 4 cubed root of x squared over 12 cubed root of x squared plus 6 cubed root of x over 12 cubed root of x squared. Okay? Now, let's go ahead and change these to powers. So I have 4x. If you have the cubed root of x squared, this is actually x to the 2/3. Okay? So the power that's the farthest over is the top. You may have learned it this way. If you have x to the 2/3 and you're trying to change it into a radical, if you took this 2/3 and kind of thumped it on the top and it fell over, the 2 would fall farther, okay, than the 3. I don't know. All right. So all sorts of rules to try to help you kind of visualize what you're doing. But this is x to the 2/3 over 12x to the 2/3 plus 6. And the 1/3 power is the cubed root and 12x to the 2/3. So 4 over 12 is 1 over 3. And this x to the 2/3 cancels this one. Okay, plus 6 over 12 is 1/2 x. And you have 1/3, start with the top power, subtract the bottom power. This is just how you simplified powers, right? A to the r over a to the s is a to the r minus s. So I'm just doing the algebra rules to simplify. So 1/3 plus 1/2 x to the minus 1/3. This is not the derivative. This is just me getting it into the shape where I can take the derivative. So f prime, the derivative of a constant is 0. The derivative of 1/2 x to the minus 1/3 is 1/2. Bring the power down, leave the x alone. Minus 1/3 minus 1, which is 3 over 3, is minus 4/3. Okay, so this is minus 1/6 x to the minus 4, I can make it 4, minus 4/3. All right, now this is f prime. So now let's think about this. Remember, standard form is to return it to the style, I guess, of the way it was presented to you. So when it was presented to you, we changed it, okay? But the way it was presented to you was using roots, not powers. So even though derivatives don't work with roots, they work with powers, we're going to change it back because we're going to be polite, okay, whatever you want to say. We're going to follow good form and bring it back to the way it used to be. So f prime of x is minus 1, okay, 6. And this negative says it's not happy. So we have x to the 4/3. So it's -1/6. The 4 goes farthest over, and this is the cubed root. And if you remember the cubed root of x to the 4th, okay, 3 goes into 4 once with 1 left over. So this is -1/6x cubed root of x. So this is where you get. Now, interestingly, let me show you something. This line right here is where you applied calculus. The rest of this problem, all the other lines, were algebra or cleanup or manipulation. But there was only one line of calculus. That was this line right here. Everything else is algebra. So one time I had a student come in, I was department chair, and he wanted to skip algebra and take calculus, and I couldn't convince him that you have to have algebra to survive calculus. And he told me I was just wanting to get money out of him for the school, and I was like, I don't think so. All right. So I sent him next door where my calculus class was actually practicing. They had formed kind of a study group and said, go talk to them. And but I went along and stood out in the hall because I wanted to hear what they said because I wasn't sure. So he told him his plan, and I had this student, and she goes, I hope you can see this. All right. So she said, she holds a piece of paper up to me and she goes, this line right here is calculus. From here to here is algebra. I never have to erase this line. I erase holes in my paper down here to do the algebra part. She said, you have to have algebra. Best explanation I ever heard. He decided he'd take algebra. So y'all, the calculus part is the easy part. It's the rest of it that just makes you have to go back and dust off everything you ever knew in your entire life. Okay, so when you ask yourself in algebra, what am I learning all this for? It's for calculus. You're learning all that for calculus. So if you never get to calculus, you never really know. All right, here we go. Here's another one. This one you will learn later on using the chain rule, but for right now we only have one rule and we're going, I don't know how to do a binomial square. I just know how to do powers. So, all right, I do know how to write a binomial square out and do that. I can do that. Let's try that. So since I don't know how to do this one, I'm going to change it into something I do know. So this is actually 9x squared minus 24x plus 16, right? And this I know how to take the derivative of. So I'm going to start cutting out a few steps. Feel free to put them in. Okay, so we have our 9. Bring the power down. 9 times 2 is 18x. Take 1 off the power. Minus the derivative of 24x is 24 times 1. And the derivative of 16 is 0. So this is my derivative. If you want to, you could say, well, I could factor out something, but you don't have to. All right. So again, if you have y is equal to 3x minus 5 times 6x minus 4, you say, well, I don't know how to do the derivative of a product. You will very quickly because the next rule we're going to go over is the product rule. But for right now, you don't know that. So you manipulate the form, okay, to something you do know. Or if later you just don't like that rule, you can manipulate it to a rule you do like, unless the teacher says you have to use that rule. So this, if you multiply this out, is 18x squared minus 18x minus 20. This is supposed to be 6x plus 4 to make that work out like that. I got busy thinking about what I want to talk to you about, and I didn't get this straightened out. Okay, so this is not the derivative. So you have 18. You bring the power down in front. Multiply it out. That's 36. Take 1 off the power. The derivative of 18x is minus 18. The derivative of a constant is 0. I don't know why my pen's not picking up some of these last numbers. I write it, but maybe I'm doing it too much on the side. Oh my gosh, I'm just sitting there talking to you. All right, now let's talk for just a minute about what you use this for. You've only got a couple more problems to go. Up until now, you have calculated up a slope two ways. One way is the algebra way, where it's y2 minus y1 over x2 minus x1. And the other way is using the derivative, which is itself a slope. This one, though, is when they talk about an average rate of change, sometimes they just call it the rate of change, then this is the way you approach the slope. You would find yourself 2 points. You would calculate up the slope the way you did in algebra class. If they want the instantaneous rate of change, then they want the derivative. Okay, because the derivative is the slope at any point along the graph, right? So keep that thought in mind, that if they say the average rate of change, so if they said, for instance, what if you had y is equal to 3x squared plus 8x? And they wanted you to do an average rate of change. Then what you would have to do is to have like, they'd say maybe on this interval, like 0 to 2. Then you would say, if this is my formula and x is 0, y would be 3 times 0 squared plus 8 times 0. So y would be 0. So my first point is 0, 0. If x is 2, y would be 3 times 2 squared plus 8 times 2. So y is 4 times 3 is 12, plus 16 is 28. So this would be 2 and 28. So you could do an average rate of change and say the slope was 28 minus 2 over 2 minus 0. So this would be 26 over 2. This is 13. So this might be the average rate of change between two locations. But if you had that same y is equal to 3x squared plus 8x, and they wanted the instantaneous rate of change, well, they usually just call it slope, instantaneous rate of change at x is equal to 2, then what you would do is to take the derivative, so it's 6x plus 8, and then you would evaluate that at x is equal to 2, because this is actually the slope function. So the slope function is 6x plus 2, and the slope would be 6 times 2 plus 8. So it's 20. Okay? Now, let's go way up here. And look at this problem again. And let's talk about y is equal to 3x squared plus 8x. And what I want to do is a commonly asked type of a question. And if it says find the tangent to the curve, y is equal to 3x squared plus 8x at x is minus 2. Now remember, a tangent is a line that just grazes a function. It just touches in one location. Now, to find a tangent, I'm looking for the equation of a line. And so remember, the equation of a line, y minus y1 is equal to m times x minus x1. So anytime somebody says find the equation of a line, you know you need two things. You need a slope and you need a point. This just sort of becomes a habit. Anytime somebody says find equation of a line, you need a slope and you need a point. Now, you know how to get a slope, an instantaneous slope at a particular x. You take the derivative. So let's start these two things off. We're going to find a slope and we're going to find a point. Okay? Now, let's talk about the point for just a second. You have this curve, and you know that x is supposed to be minus 2. So if you substitute that in there, you'd have y is equal to 3 minus 2 squared plus 8 times minus 2. And so this would be 12 minus 16. So y is negative 4. So your point is negative 2, negative 4. Now, let's talk about the slope. The slope is the derivative. So y prime, well, let's write it down here where you can see it. Y is 3x squared plus 8x. Y prime is 3. Bring the 2 down. 3 times 2 is 6. Leave the x alone, take 1 off the power, and the derivative of 8x is 8. So and this is the slope, right? At x is equal to negative 2, the slope is 6 times negative 2 plus 8. So the slope is negative 12 plus 8. The slope is negative 4. So you'd have y minus y1 is equal to the slope times x minus x1. So y plus 4 is equal to minus 4x. Minus 4 times minus 2 is minus 8. So y is equal to minus 4x minus 12 after you move the 4 over. And it's supposed to be the tangent at x is equal to negative 2. So let's see. So this is from Desmos using their software they let me use. So the red curve is part of the original curve, and the blue curve is the tangent. And see right here at x is equal to negative 2, see how the blue and the 4 for just this instant touch each other. So you can see that the tangent is verified. And you can use your calculator to say, okay, does that look right? And yes, it is. Okay, let's do a different version of this. This will be our last problem. So what if I said find the points or maybe there's just one. So I'm going to put this in parentheses on the graph of y equals 2x cubed plus 3x squared minus 12x plus 1, where the tangent is horizontal. Now, let's pretend you're on the test. And you've done tangent questions and you've done derivatives, but you've not done one where it has to be horizontal. I mean, this is new. So let's think for a second. So when you're on the test, they ask you this question and you've not seen one like that, you can get perturbed or annoyed or scared or um, I don't know, just freak out. I mean, whatever. There's all sorts of different emotions you could feel. But if you just stay in that state and don't do anything, blank is definitely wrong. So let's start trying to at least figure out something we can write down, maybe get some partial credit, and maybe it'll hit us what we need to do with it, if we start kind of getting the ball rolling. So let's look at it. Now, I know that anytime they ask me for a tangent or a line or something like that, I know I'm going to have to try to get it into this formula. And I know that that means I need a slope and I need a point. Okay, so now let's kind of look through here to see if there's anything. Now this is, well, wait, okay, now if it's horizontal, right? If it's horizontal, don't you know something about the slope? You may not know anything about the point, but don't you know something about the slope? Yes, you do. Okay, what you know is that if it's horizontal, the slope is 0. But I don't have a point yet. Okay, and in fact, the point is what they want you to find. True? So let's see what we can do with this. So let's think about this. If the slope is 0, and all I've got is the function itself, can you get to the slope? Do you know anything else about the slope besides that it's supposed to be 0? Well, you know the derivative is the slope, right? So let's see where we get. So y prime would be 6x squared plus 6x minus 12, correct? Which is, I can factor out a 6, x squared plus x minus 2, which is 6 times x plus 2, x minus 1, right? And wait a minute, we said the slope was 0, right? 0, 6 times x plus 2 times x minus 1. And this you know how to do from algebra. Okay, so 6 can't be 0, right? But x plus 2 could be 0, or x minus 1 could be 0. So x is minus 2, x is 1. Okay? All right. Now, this says find the points on the graph. So normally when somebody means points, they mean an ordered pair. Okay? So let me write this down again where you can see it down here. So if we have y is equal to 2x cubed plus 3x squared minus 12x plus 1, then if x is negative 2 and you substitute negative 2 in there, okay, I got y is equal to 21. So you would substitute that into everywhere, right? So the point is negative 2, 21. And if x is 1, y turns out to be negative 6 after you substitute 1 into here. So 1, negative 6. I'm thinking that's what it is. Now, let's say this is only one of 2 questions on the test, and I'm not willing to throw 50 points away by thinking this is what it is. Okay, so if I had a horizontal line that passed through negative 2, 21, that line would look like this, right? Y is 21. And this would look like y is negative 6. So let's look. And the red is my original function. And this top line here that's blue, this is y is 21. See how it passes right there? And this bottom line is y is negative 6. And here it is down here at 1. So you can, if you're allowed to have your graphing calculator, plot these and see what it is. Because if you had done this, let's go back here a minute. If you don't believe the 21 horizontal thing, let's just look at this one. So you would go y minus 21 is equal to the slope, which is 0, x minus a minus 2. So y minus 21, 0 times anything is 0, y is 21. See how you get that for horizontal? Okay. And the same thing here, y minus a minus 6 is equal to 0 times x minus 1. So y plus 6 is equal to 0, y is equal to negative 6. Okay, now, so let's talk for just a second. This is the power rule. We're going to do the product rule next, the quotient rule after that, and then we're going to do everybody's favorite, which is the chain rule. I actually like the chain rule, but sometimes it drives people kind of crazy. But if you kind of go into it as it's a puzzle and think of it as sort of a game, it's not too bad. You just have to keep track of where you're at. So again, there will be a link to the proofs for this, and be sure you look down in the description and find the link and go check those out. Good luck with the power rule. I'll look forward to talking to you about the product rule and the quotient rule and my all-time favorite, the chain rule. So I will talk to you later.